Hello everyone. Today in this video, we are going to cover Kubernetes autoscaling, which are horizontal pod scaler, autoscaler, and vertical pod autoscaler. So here, Kubernetes autoscaling helps manage workflows efficiently by ensuring applications get the right amount of resources while minimizing costs. So there are two main autoscaling mechanisms, which are horizontal and vertical. So if you see in the horizontal pod autoscaler, it scales the number of pods based on CPU, memory, or custom metrics. So if you see in the vertical pod autoscaler, it adjusts CPU and memory resources requests for existing pods dynamically. So this video will provide you a step-by-step approach to setting up and using HPA and VPA in Kubernetes. So if you see the prerequisites, we need a running Kubernetes cluster like Minikube, BK, GK, AK, or etc. And also a kubectl install and configure, and basic knowledge of Kubernetes deployments and pods. So in the step one, we'll install horizontal pod autoscaler, which is HPA. So here the horizontal pod autoscaler requires the metric server to collect CPU and memory usage data. So first we'll install the metric server on Minikube. So I'll use this command for that. So here the metric server is added. So we need to verify the deployment. So here it not yet started. So in this meantime, we will install the vertical pod autoscaler. So here VPA requires specific components to function properly. So first we'll clone the VPA repository and then we'll deploy the components. So it is done. Now let's deploy the VPA components by using this command. So here VPA components are deployed. So let's verify by using this command. So two created, one is still creating. So here you can see the three components which are admission controller, recommender, and updater. So these three components are running now. So let's check the HPA whether it is running or not. So here you can see our metric server is also running. So we can use the HPA also now. So first we'll see about the horizontal pod autoscaler. So here HPA automatically scales the number of replicas of a deployment based on CPU or memory usage. So first we'll deploy a sample application. So I'll take this application for that. So I'll create the deployment.yml. I'll paste it here. So here two replicas will be created. So container port number will be 80, and here I gave the resources as the CPU will be 250 M and limits of CPU will be 500 M. So I'll save it and now I'll deploy the deployment.yml. So it got created. So let's check once. So here you can see our both pods are running. So now we'll expose the deployment to create a service to access the Nginx pods. So for that, I'll use this command. So here our service got created. So if we check, So this is the our deployment service. So with port number 80. So now let's create a horizontal pod autoscaler now. So for that we have to create a file which is called as HPA.yml. So here I'll take this YML code and create HPA.yml file and paste it here. So here you can see the minimum replicas will be 2 and maximum replicas will be 5. So here I gave the average utilization to 10. So if the target reaches to 10, new pods will be created. So here I gave the period seconds, which means the cooling period to 30 seconds only to show you immediately after doing everything. So here I'll save this and I'll apply it. So our auto horizontal pod autoscaler is created. So we can check by using this command kubectl get HPA. So here you can see the CPU is at 0% currently. So if it reaches to 10%, another pod will be created. So I'll show you right now. So now let's generate load to test auto scaling. So to see auto scaling in action, we have to generate CPU load. So for that, I have to take another window here. So here I'll install the load generator. So it will open pod. So inside this, we'll run this command. So here you can see the load is being generated. So here, if you check it here, the CPU currently is at 0%. So it have to reach to 10%. So if you see the pods, there are currently 3 pods running. 2 are our Nginx deployment pods and another one is of the load generator. So after CPU hits 10%, so here you can see there are 3 pods. So another pod will be created and totally it will become 4 pods. So let's wait. So your load is being generated. So it will take some time. So we have to wait for that. So you can check HPA scales of pod by using kubectl get HPA and kubectl get pods. So here you can see the CPU hit the 10% target. So let's check for the pods. Let's wait for some time. It will be created. The CPI have to go more than 10%. So after that, the pod will be created. So it's taking much time. So here I think the load is not enough. So let's go for the vertical pod autoscaler here. So here the VP automatically adjusts CPU or memory requests of a running pod based on usage. So first let's create a VPC resource and define VP for the Nginx deployment. So here we already installed the VPA components. So let's create the VPA.yml. So here the update mode is auto and the target is for Nginx deployment. So I'll save this. Let's check whether so the CPU's load is not enough. So it's okay. Let's go for the VPA and let's delete the HPA now. Okay, so let's go for the VPA now. So we created the VPA.yml. So now let's apply. So you can check by using kubectl get VPA. So here you can see the Nginx VPA is created. So CPU is at 35M. So here also you can increase the load. So here you can check VPA recommendations here. So here you can see here lower bound means minimum CPU or memory required. Upper bound means maximum it should have. And the target is the ideal value. So here you can see all those things. So here lower bound CPU is at 25 and memory is at this and target is at 35. So here in the upper bound CPU and memory values are this. So those are the recommended CPU or memory values. So for this also we can generate load to test auto scaling. So to see auto scaling in action, we have to generate CPU load by using these two commands which we use for the HPA. So let's try to use whether will it work or not. So inside the pod, we have to run this. So the load got generated. So if the maximum load reaches, so after some time, check if pods restart with updated requests or limits. So I think it would take a lot of time. We can check right now. So here you can see one pod got created, like deleted and got created recently. So I think this is because of HPA. So for VPA, it would take a lot of time. So I can show you the output now. So as it would take a lot of time. So that's how the VPA works. So let's try to check HPA once again. So here it reaches 68%. So here you can see there were only two pods. Now here you can see three new pods got created because of the HPA. So which is horizontal pod auto creation. So that's how the HPA works. I want to show the VPS output also, but it would take a lot of time. So let's leave for this. So if you want, you can check it. So that's how HPA works. So as the load got decreased here. So if the load gets decreased, the newly created pods will be deleted automatically because of the HPA. So here you can see the load became 68% to 0%. So I gave the cooldown period to only 30 seconds. So after 30 seconds, these newly created three pods will be deleted. Only two pods will remain. So let's check. So here you can see only two pods remained. As you can see, there were total five pods running because as it target reached more than 10%. So now after the target reached to 0% or less than 10%, the pods got deleted, and these are the two pods which we gave in the deployment.yml. So that's how HPA works. So for the VPA, it would take time. Let's try once again. So here the VPA got created. So here you can see both pods are of more than 4 minutes. So if you see one restart in either of these two pods, then the VPA, we can see that VPA is working. So So I think it would take a lot of time, but let's see let's give it a try. So these are using 27, 26M. So if we see the recommendation, the upper bound is at 3395. So it is impossible to see the output right now. So it would take a lot of time. But the lower bound is at 25M. So we have to see the upper bound. So it would take a lot of time. So it reached to 27M. So I think I can't show you the output here as it take a lot of time. So in the conclusion, HPA and VPA help Kubernetes automatically adjust resources based on workload. So here HPA scales pods up or down, while the VPA adjusts CPU and memory requests. Using them together ensures efficient resource management and better application performance. So try them out to keep your cluster running smoothly. So, so yeah, this is about Kubernetes autoscaling, which are HPA and VPA. So that's it for today. So yeah, thank you.